This next lesson is about negative and fractional exponents. Negative exponents have to be moved to the denominator or numerator to become positive. It's opposite of wherever the exponent began. So if I had something like one over x to the negative third, to make it positive, I'd move it to the top, and it'd be x to the third. Or if I had something like y to the negative fourth, to make it positive, I'd move it to the denominator, and it become 1 over y to the positive fourth. So all you're doing is moving to the top if it's negative on the bottom, or moving to the bottom if it's negative on the top. So one more, if I had x to the negative third divided by y to the negative fourth, I'd move my y to the top, so it'd be y to the fourth in the numerator, and I move my x to the bottom, so it'd be x to the third in the denominator. Fractional exponents. An exponent that's a fraction, if I had x to the 2/3, the numerator in my fraction is my power number. Power is your exponent. The denominator is your root number. So if I were to rewrite it as a root, remember a root, you're used to square roots. So x to the second, since 2 is my power, so that's my exponent. Power is an exponent. And then over 3 would be my root number. And then the root number goes inside the root symbol. So power over root. Power over root. Something that you need to remember. Some other things that you need to know, or need to remember actually, because you should know. X to the fourth times x to the fifth. If you have two of the bases the same and you're multiplying them, you add your exponents. So it'd be x to the ninth. So we're adding the exponents. Same base, add the exponents. If I had y to the fifth divided by y to the second, if you remember, same base, dividing, you subtract the exponent, so it'll be y to the third. So dividing, you subtract. And one more that you should remember. X to the third raised to the sixth. This is a power raised to a power, because I have x to the third, which is a power, and then raised to the sixth, which is another power. You multiply power raised to a power. So it'd be x to the 18th. So we're going to do a couple and express it in simplest form. So that means you don't want any negative exponents. So the first thing you want to do is move any negative exponents. So y to the negative fifth has a negative exponent, and x to the negative third has a negative exponent. One thing that they try to trick you on, and some people get confused with, the 4 times x to the negative third are separate terms. The 4 is by itself, and x to the negative third is by itself. So the only thing that's going to move when we move the variable is x to the negative third. the 4 is going to stay in the denominator because it doesn't have an exponent on it. If it was in parentheses, like the next one, then that's different. So I'm going to write everything that's going to stay first. So x squared is going to stay, 4 is going to stay, and y to the second is going to stay, because they all have positive exponents or no exponents, so they don't move. Y to the negative fifth has a negative exponent. So if it's negative in the numerator, it's going to move to the denominator. So it would be y to the fifth if I move it. And then x to the negative third has a negative exponent in the denominator, so I have to move it to the numerator for it to become positive. So I'd have y, or x to the third in the numerator. So now I have two of the same base, an x to the second and x to the third. We just talked about it before, that if it's the same base, you add your exponents. So I have x to the fifth divided by 4, and then y to the second times y to the fifth would be y to the seventh, because I'm going to add my exponents. And I can't do anything else because I don't have any x's or y's in the numerator or denominator to cancel, so I'm done. The next one's a little bit different because I have a negative exponent outside a whole entire parenthesis. So first you want to look inside the parentheses, see if I can simplify anything, which I can't because I don't have any like terms. I have a 3, an x, and a y. So now I want to raise everything to the negative second power. Since it's all one term, I can raise everything to the negative second. So I'd have 3 to the negative second, x to the fourth to the negative second, and then y to the negative first to the negative second. All divided by 4x to the negative third, y to the negative fourth. So 3 to the negative second, I'd have to move before I square it because I don't have any power on 3 to the on 3. So I want to move that first before I square it because it's a negative exponent. X to the fourth is raised to the negative second, so that's a power raised to a power, so I'm going to multiply those before I move it. And then y to the negative first to the negative second is a power raised to a power again, so I'm going to multiply my exponents again. So I'm moving 3 to the negative second before I square it, because it's a negative exponent. X to the fourth to the negative second, I'm going to multiply my exponents, so I'm going to have x to the negative eighth. 4 times negative 2 would be negative 8. And then I'm going to multiply negative 2 times negative 1, so that's going to become positive, and it'll be y squared. I'm not moving anything else yet. I just want to make sure that everything inside my parentheses is simplified first. So now I can move all my negative exponents and square my 3. So y to the negative eighth, or x to the negative eighth, is going to move to the bottom. Y to the second is going to stay on top. 3 squared, I know will become 9. 4 staying on the bottom, so I'm going to have to multiply those. Now I can move my negatives. So x to the negative eighth moves to the bottom and becomes positive 8. X to the negative third is going to move to the top and become a positive 3. And then y to the negative fourth is going to move to the top and become y to the positive fourth. So now I want to simplify and cancel anything that I can. So I can combine x to the, I can combine y to the second and y to the fourth. And that will become y to the sixth because you add the exponents if they have the same base. I can multiply 9 times 4, that will give me 36 in my denominator, because that's where it is. And then x to the third divided by x to the 8th, I can cancel 3 x's, so it'll become x to the 5th in the denominator. And that's my answer. I can't cancel any more y's or x's and can't simplify my values anymore. So I'm done. Last one, then I have 3 that you want to do on your own and bring them to class. Remember, order of operations is PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. So the first thing I want to do is simplify what's inside my parentheses. So y to the negative 5th divided by y to the negative 11th. Remember, you subtract your exponents if they're dividing. So if I subtract my exponents, I would have y to the negative 5th minus a negative 11th. So really I'm going to add that. Because I'd have y to the negative 5th minus negative 11. So if I was looking at it, it'd be y minus a negative, which would change to a positive. So I really have y to the negative 5th plus 11 would give me y to the 6th inside my parentheses. Still raised to the 1/3. There's 2 ways that this could be simplified. You can simplify it into a power and a root, which would become y to the 6th and the 3rd root, because remember it's power over root. Or, if it's a power raised to a power, remember you multiply your exponents, so it'd be y to the 6th times 1/3. So 6 times 1/3 would be y to the 6 over 3, which would become y to the 2nd, because 6 divided by 3 would become 2. This is the same idea. You want to, when you're simplifying roots, you need to think about how many groups of 3 I could pull out of y to the 6th. So I could pull out 2 groups of 3 out of 6 y's, correct? So I'd have y squared. Same idea, just a little bit different. Different way of thinking. So now I want you to try these 3 examples on your own and simplify them all away, and then bring them to class tomorrow.